Let's imagine something incredible here, right from the start. Picture a towering structure that stretches from the ground beneath our feet all the way up into the dark silence of space, with no engines, no explosions, no rockets. Instead, this structure, a space elevator, could carry cargo and maybe one day people to the stars in a continuous smooth ascent. It's a vision that almost sounds too fantastical to be real, but it's a serious concept that scientists and engineers are putting genuine thought into. The space elevator isn't just science fiction. It could be one of the most revolutionary breakthroughs in space travel and exploration. To understand where this bold vision comes from, we need to go back over a century to the early ideas that inspired it. The concept of a space elevator can actually be traced to a Russian scientist, Konstantin Tsiolkovsky, who was an early pioneer of astronautics. In 1895, Tsiolkovsky looked at the newly completed Eiffel Tower in Paris and imagined a structure that could reach much higher, all the way into space. He wondered, what if we could build a tower tall enough to reach geostationary orbit? At that height, an object would orbit the Earth at the same speed that Earth rotates, effectively staying over one spot. Tsiolkovsky's idea was purely theoretical at the time. He knew materials to support such a structure didn't exist, but it sparked a question that has intrigued thinkers ever since. Fast forward to the 20th century, when the idea gained more traction. Engineers and scientists started exploring the concept again, especially after the space race and advancements in aerospace engineering. In the 1970s, a scientist named Jerome Pearson, working with NASA, developed the first serious design for a space elevator. He proposed a cable that would stretch from Earth's surface to a counterweight in space, using centrifugal force to keep it taut. Pearson's work was followed by proposals from other engineers, including Arthur C. Clarke, who helped popularize the space elevator concept in his sci-fi novel, The Fountains of Paradise. Clarke's story made the concept accessible to the public, inspiring both dreamers and scientists to think about what it might take to actually build one. Now, let's get into why we'd want to build something like this in the first place. For one, getting into space is incredibly expensive. Rockets rely on massive amounts of fuel and have to fight against Earth's gravity in one big explosive push. A single launch can cost tens of millions, even hundreds of millions of dollars, and it's far from environmentally friendly. But imagine if we had a cable that connected Earth to space, like an elevator shaft. We could lift materials, equipment, and even people up and down without needing to burn tons of fuel every time. A space elevator would make space travel cheaper and more energy efficient, and it could open the doors to regular, reliable access to space. Instead of launching a rocket every time, we'd have a continuous line from the Earth to space, almost like a railroad to the stars. Not only would this lower the cost, but it would also reduce the pollution and environmental impact associated with traditional rocket launches. So the elevator isn't just a cool idea, it's a solution to some of the biggest limitations in space exploration today. So what will we be exploring in this journey? In this video, we're going to dive deep into the concept of the space elevator. We'll look at the science, the engineering challenges, the benefits, and of course, the vision for what such a structure could mean for our future in space. We'll talk about the materials needed to make this dream a reality, the energy required to lift cargo, and even how it might feel to take a ride on this incredible structure. And there's more. We'll also think about what it would mean for humanity to have regular, easy access to orbit and beyond. Alright, so we know what a space elevator is supposed to achieve, but how does it actually work? Let's break it down in a way that's easy to picture. Imagine a super strong cable stretching up from the Earth's surface to a point in space about 35,786 kilometers above the equator. That's roughly 22,236 miles. This point is called geostationary orbit, where an object in orbit moves at the same rate as Earth's rotation. Essentially, if something's at that altitude, it will stay directly above the same spot on Earth, moving in sync with our planet. That's crucial for the space elevator because it means the tether can stay fixed and taut between Earth and space. At the top of this cable, we'd have a counterweight, something heavy that pulls on the other end and keeps the cable stretched tight. Think of it like a playground swing with weights at both ends, keeping it stable as it spins. This counterweight could be anything from a space station to an asteroid that we haul into position, giving the whole structure balance and stability. Now, once the cable is anchored on Earth and counterbalanced in space, we'd have climbers, like high-techable cars, that travel up and down, carrying cargo, equipment, or even people. The design of a space elevator needs to be pretty specific for it to work. First off, the cable has to be incredibly strong. We're talking about a material that can withstand the tension of Earth's gravity while being lightweight enough to not weigh itself down. For decades, this seemed like pure science fiction because no material was strong enough to handle that kind of stress. But with the discovery of carbon nanotubes and more recently graphene, we're getting closer to materials that might just be up to the task. These materials are lighter than steel but about 100 times stronger, meaning they could be used to create a cable capable of supporting its own weight and handling the loads placed on it. Now, what about the climbers themselves? These climbers would be designed to latch onto the cable and ascend, gradually moving cargo from the ground all the way up to orbit. They'd need a power source, which could come from solar panels mounted on the climber itself or from lasers beaming energy from Earth. Imagine giant laser beams powering these climbers on their journey upward. It's a futuristic solution, but it's actually one of the most realistic ways to provide power over such a long distance. So as incredible as this sounds, it all really hinges on one critical factor: the strength of the cable material. This is the biggest challenge in making a space elevator a reality. Right now, the materials we have, like steel and Kevlar, are far too heavy or not strong enough for this kind of structure, but new developments are happening all the time. Scientists are working with materials like carbon nanotubes and graphene, which have impressive strength-to-weight ratios. Carbon nanotubes are essentially tiny cylindrical carbon structures, and they have properties that make them ideal for the space elevator's cable. They're strong, flexible, and incredibly lightweight. However, creating a cable of this magnitude out of carbon nanotubes isn't easy. So far, we can make nanotubes only in short segments. Scaling this up to make a single, unbroken cable that stretches for thousands of miles is a huge technical challenge. But with advances in material science, some researchers believe that it's just a matter of time before we can produce these materials on a large enough scale. At this point, you might be wondering, why go to all this trouble? Aren't rockets working just fine? And yes, rockets do work, but they're not the most efficient way to reach space. Rockets require enormous amounts of fuel, and they're incredibly expensive. Plus, rocket launches are loud, environmentally taxing, and they create a lot of waste in the form of booster stages and fuel emissions. By contrast, a space elevator would offer a quieter, cleaner, and far more sustainable way to access space. Think of the space elevator like an elevator in a building. Instead of burning fuel to blast off, you're taking a slow, steady ride up to orbit. The goal is to make access to space as easy as taking an elevator from one floor to another, something so routine that we could use it for regular trips, cargo transport, and eventually, even tourism. Imagine how much more accessible space could become with an elevator that can quietly carry cargo and people without the explosive force of a rocket. So let's talk about where we'd actually put a space elevator. This is a structure that needs to stretch straight up from the surface of the Earth to geostationary orbit. To make that happen, we'd need a very specific location, ideally somewhere on the equator. Why the equator? It's all about stability and balance. The Earth's rotation provides the centrifugal force needed to keep the tether taut, and the equator is where this force is the most consistent and balanced. A lot of people picture a space elevator in the middle of a bustling city, but it would actually be more practical to build it somewhere remote, away from air traffic and possibly over the ocean to minimize safety risks. One popular idea is to build the anchor on a floating platform in the middle of the Pacific Ocean. This would keep the structure far away from major population centers and minimize risks if there were ever any issues with the cable. Plus, a floating platform could be adjusted to compensate for ocean currents, storms, and other environmental factors. It's a bit like an offshore oil rig, but designed to handle one of the most ambitious projects in human history. Once we have the location, the next challenge is to make sure the whole structure remains stable. A space elevator can't sway with the wind or wobble in a storm. To keep everything secure, engineers would need to develop advanced stabilization systems, This could include things like counterweights and tension adjustments that help absorb any movement in the cable. It's similar to how modern skyscrapers use dampening systems to stay stable during earthquakes, just on a much larger scale. Another issue is that the cable would be exposed to everything from lightning strikes to high-altitude winds, not to mention atmospheric changes. So, the cable would likely need a protective coating or system that could handle extreme weather, intense sunlight, and maybe even small impacts from flying debris. And because it's anchored in the ocean, engineers would have to think about waves, salt corrosion, and other challenges that come from being in a harsh, saltwater environment. Alright, now that we've covered the structure itself, let's talk about the power. Once we've got a climber attached to the cable, how do we power it for a journey that could take days or even weeks to reach orbit? One interesting option is solar power. Imagine a climber with large solar panels on its surface, collecting energy directly from the sun as it ascends. Solar power works well in space, where there's no atmosphere to block sunlight, but it has limitations lower down, where clouds or nighttime could interfere. Another innovative idea is to use laser power beamed up from Earth. Ground-based lasers would direct energy at photovoltaic cells on the climber, giving it the power it needs to keep moving up the cable. It's like wireless charging for your phone, but on a much larger scale. The lasers could provide a steady supply of energy, day and night, avoiding any downtime during the climber's ascent. This laser power system is already being tested in small-scale prototypes, and while it's not quite ready for something as big as a space elevator, it's a promising technology that could make this project feasible. Now, while all of this technology sounds complex and futuristic, the truth is that real people are working on it right now. Around the world, teams of engineers, scientists, and even students are tackling the challenges of a space elevator. From designing stronger materials to figuring out the logistics of a floating base, these experts are breaking down this ambitious project step by step. Many of them are inspired by the dream of space exploration and the idea of making it more accessible for everyone, not just astronauts or billionaires. These people aren't just dreaming, they're testing, creating prototypes, and even competing in contests to develop solutions. NASA has even sponsored competitions in the past to encourage innovation in climber design and power systems. It's amazing to think that the groundwork for a space elevator is being laid by individuals who believe in this vision, and their efforts bring us closer to making it a reality. Now let's dive into some of the big challenges that a space elevator would face, starting with threats from space itself. Our planet is constantly bombarded by debris and micrometeoroids. Most are tiny bits of rock or fragments of old satellites, but even small objects can be dangerous when they're moving at tens of thousands of miles per hour. This debris could tear through the cable or damage the climbers moving along it, causing serious risks for the entire structure. To address this, designers are considering protective coatings or even shield systems that could cover parts of the cable. Some have proposed placing a series of shields along the length of the cable, which would act like armor to deflect or absorb impacts. These shields could be reinforced with resilient materials like graphene, adding an extra layer of protection. The risk from space debris can't be completely eliminated, but with careful planning, we could reduce the impact and make the structure safer. Then there's Earth's atmosphere itself. At lower altitudes, the cable would face extreme weather, high winds, lightning, storms, and other elements that could put stress on the structure. Remember, this cable would stretch tens of thousands of miles through all layers of the atmosphere, from sea level up through the stratosphere and beyond. Each layer presents its own challenges, from high winds at lower altitudes to the near vacuum conditions in the upper atmosphere. Lightning strikes, for instance, could damage or even sever the cable if it's not adequately protected. To protect against lightning, engineers might incorporate conductive materials into the cable, allowing any electrical charge to disperse safely. Another option could be to add specialized lightning rods or grounding systems along the length of the cable. And as for wind, advanced dampening systems would help absorb any sway or tension from powerful gusts. By addressing each atmospheric layer with tailored solutions, engineers could manage these environmental threats more effectively. Of course, even if we find the perfect material for the cable, it would still face long-term wear and tear. This cable wouldn't just need to be strong, it would also have to be resilient enough to handle constant use over decades, if not centuries. Think about an elevator cable in a skyscraper, which needs regular maintenance and eventually replacement. Now imagine a cable that's 35,786 kilometers long. Maintenance and durability become huge considerations. The constant stress and exposure could weaken the cable over time, even with the strongest materials. Engineers would need to build in redundancies, maybe by creating a multi-strand cable system where each strand can bear part of the load. This way, if one section starts to wear down, it won't compromise the entire structure. Additionally, there's the idea of a self-healing material, something that could potentially repair itself when damaged. We're not there yet technologically, but advancements in material science might bring us closer to that solution in the future. Powering the elevator over such a long distance is another significant hurdle. Even with solar panels or laser beams, maintaining a consistent energy flow for days or weeks without interruption is challenging. Solar panels would need to be efficient enough to store excess energy for use when sunlight isn't available, and laser power, while promising, would need to operate with pinpoint accuracy, targeting the climber over vast distances. There's also the issue of power loss as energy travels along the cable. Engineers are exploring the potential for wireless energy transfer or building smaller charging stations along the cable's length, where climbers could stop to recharge. Another idea is regenerative braking systems that could capture and store energy as climbers descend, feeding it back into the system. By maximizing energy efficiency and exploring innovative power solutions, we could address this energy challenge and keep the elevator operating smoothly. Finally, we can't overlook the human and financial costs involved. Constructing a space elevator would be one of the largest and most complex engineering projects in history. It would require billions, if not trillions of dollars, extensive global cooperation, and a workforce of thousands of skilled engineers, scientists, and technicians. On top of that, the project would need constant monitoring, maintenance, and updates to keep it safe and operational. Beyond finances, there's the question of safety for the people involved. Workers building and maintaining this elevator would be facing extreme conditions and high risks, particularly those working on the cable itself at dizzying altitudes. This project would likely be a multi-generational effort, with new generations of engineers and scientists taking up the work and improving the design as technology advances. One of the most exciting aspects of a space elevator is that it could redefine how we launch rockets into space. Right now, launching a rocket from the ground requires an incredible amount of fuel to break free from Earth's gravity. But with a space elevator, rockets could be sent up the cable to a launch platform in space, which means they wouldn't need nearly as much fuel or thrust to reach their destinations. Think about it. Launching a rocket from geostationary orbit, where gravity is weaker, would be like taking off in a low-gravity environment compared to Earth's surface. This has huge implications for space exploration and resource efficiency. By using the elevator to transport rockets, we could potentially reduce launch costs by a factor of 100 or more. It's a game changer, especially for deep space missions where fuel savings are crucial. Imagine a future where we use the elevator to deliver rockets and satellites to space, almost like a conveyor belt. The savings in fuel alone would allow us to send more missions and larger payloads than ever before. But it's not just rockets. A space elevator could also transport cargo, building materials, and even essential supplies for space habitats. Think about a scenario where we're building a colony on the Moon or Mars. Instead of repeatedly launching heavy payloads from Earth's surface, we could load construction materials onto climbers, sending them up to an orbital shipping station. From there, we could assemble and send cargo pods or ships to the Moon, Mars, or wherever we're building. Imagine using the elevator to send modules, equipment, or even food supplies up into space at a fraction of the cost and environmental impact. This system would allow us to move tons of material into space without the stress, expense, and pollution of constant rocket launches. We could establish storage depots, floating in geostationary orbit, where resources are ready to be sent wherever they're needed in the solar system. Now here's where it gets really interesting. A space elevator wouldn't just be for cargo or rockets, it could open up space travel to ordinary people. Space tourism could go from being a luxury for billionaires to an achievable dream for many. Imagine boarding a climber with other passengers and taking a peaceful, steady ride up into orbit. No explosive launch, no intense G-forces, just a gradual, scenic journey up through the Earth's atmosphere, with stunning views along the way. Tourists could visit an orbiting hotel, a space station, or even connect to lunar-bound flights. The whole process would feel more like a long-haul train or cruise experience, where people could relax, take in the sights, and arrive in space without the anxiety or danger of a rocket launch. This could bring space within reach for countless people, and could change how we experience our own planet from above. A space elevator could also revolutionize how we maintain and expand space stations. Take the International Space Station, for example. Currently, resupplying the ISS involves launching rockets carrying everything from food to scientific equipment. But if we had a space elevator, we could simply send supplies up via climbers, making restocking as routine as a truck delivery. This would mean more consistent and less costly access to orbiting habitats, helping them to stay well-resourced and operational. Beyond that, the elevator could be used to transport building materials for expanding existing space stations, or even constructing entirely new habitats in orbit. Over time, we could create a network of stations, research labs, and habitats connected by regular space elevator trips, forming a bustling ecosystem in low Earth orbit and beyond. Each trip up the elevator would deliver parts, supplies, and even scientific instruments, allowing for faster progress in space exploration and settlement. Let's not forget the environmental benefits here. By shifting from rocket launches to elevator transport, we're cutting down on emissions and fuel consumption significantly. Traditional rocket launches release tons of carbon dioxide and other pollutants into the atmosphere, which isn't sustainable on a large scale. A space elevator would be electrically powered, potentially running on renewable sources like solar power. It's a cleaner, quieter, and greener way to access space. With a space elevator, the journey to orbit becomes much more environmentally friendly. The entire system could even serve as a stepping stone for a larger space-based power network. Imagine powering the elevator with solar arrays in space, beaming clean energy back down to Earth. The elevator wouldn't just be an infrastructure project, it could become a symbol of sustainable space exploration and our commitment to preserving our home planet. Now let's imagine a future where one space elevator isn't enough. As space exploration and commerce expand, a single elevator could quickly become crowded with traffic from rockets, cargo, and even tourists. To meet this demand, scientists envision a network of multiple space elevators placed strategically around the equator. Each elevator could be dedicated to specific tasks, one for heavy cargo, another for passenger transport, and others for scientific research or satellite deployment. Think about how this would change space access. With multiple elevators, we could maintain a continuous flow of materials, supplies, and people into orbit. It would be like having multiple highways to space, with each one designed to handle a different type of traffic. We could even have international elevators, with countries partnering to build and operate their own, transforming space into a collaborative, shared domain. This network would allow us to scale up operations massively, and could support a space-based economy with almost unlimited potential. With more space elevators, we could build an entire infrastructure in orbit. Picture this: supply depots, transfer hubs, and even space docks, where interplanetary missions can be launched directly from geostationary orbit. These stations could serve as pit stops for ships headed to the Moon, Mars, or beyond, reducing the need for heavy launches from Earth. Ships could be assembled and launched from these orbital hubs, equipped with everything they need for the long journey, bypassing the fuel and energy constraints of a traditional launch. This orbiting infrastructure could also host research labs, manufacturing facilities, and even tourism hubs. Imagine scientists conducting zero-gravity experiments in orbit without having to worry about the limitations of a spacecraft. Manufacturers could develop new materials in low gravity, leading to technological advances that wouldn't be possible on Earth. This setup would turn orbit into a thriving, interconnected ecosystem where people work, explore, and innovate on a scale that's never been possible before. A global network of space elevators wouldn't just be a scientific achievement, it would represent unprecedented international collaboration. Building these elevators would require the resources, expertise, and cooperation of multiple nations, potentially uniting countries in a shared pursuit of space access. Just like the International Space Station, these elevators could be symbols of unity, where nations work together for the common goal of exploring and utilizing space. And the economic impact? Huge. Each elevator would create jobs, spur technological advancements, and open new industries. The construction alone would require advances in engineering, materials science, and robotics, leading to innovations that could be applied back here on Earth. The space elevator industry itself could become a trillion-dollar market, driving economic growth in ways we haven't yet imagined. Countries would invest in their own elevators, creating a competitive yet collaborative network that could bring prosperity and opportunity to nations around the world. With multiple space elevators, we're also setting up the infrastructure needed for off-world colonization. Think about how much easier it would be to build colonies on the Moon or Mars if we could reliably transport huge quantities of supplies and materials to space without relying on rockets. Elevators could make it practical to send prefabricated habitats, equipment, and life support systems to a staging point in orbit, where they could then be shipped out to other planets. This steady stream of supplies would be a lifeline for colonies on the Moon or Mars, making it possible to establish a permanent human presence there. We wouldn't have to worry as much about the logistical and financial burden of resupplying far-off colonies because the space elevator network would offer a reliable, low-cost solution. This vision brings us closer to a future where humanity isn't just visiting other worlds, we're settling them. Eventually, space elevators might not be limited to Earth. If we can build one here, why not build them on the Moon or Mars? These elevators would be much smaller since both the Moon and Mars have weaker gravity and lower orbits, meaning the materials required wouldn't need to be as strong. A lunar elevator could connect a base on the Moon's surface to a point in orbit, allowing easy access to lunar resources and making it more practical to transport people and materials between the Moon and Earth. Mars could also benefit from a space elevator. With its lower gravity, a Martian elevator could make it easier to launch missions from Mars to other planets in the solar system. In the long run, space elevators on multiple planets could create a whole new network of interplanetary travel, allowing us to move resources and people between Earth, the Moon, Mars, and beyond. This interplanetary network of elevators would represent humanity's expansion into the solar system and make our species truly multiplanetary. Let's talk about the technology that would make all of this possible, starting with the materials. The main challenge with a space elevator is creating a cable strong enough to support itself over tens of thousands of kilometers. Fortunately, there have been major breakthroughs in materials science that bring us closer to solving this problem. Nanotechnology, for example, has given us materials like carbon nanotubes and graphene, which are hundreds of times stronger than steel, but incredibly lightweight. These materials could form the backbone of the space elevator cable, capable of withstanding the immense tension without snapping. Now, while we're not quite there yet, scientists are working on ways to produce these materials at scale. Imagine weaving billions of these nanotubes into a super strong, flexible cable that could stretch from Earth into space. And as research continues, we're likely to discover even stronger and more durable materials. The space elevator concept has sparked innovation in material science that could impact industries far beyond space travel, transforming everything from construction to electronics. Another key piece of technology is power. How do we fuel a climber moving up a 35,000-kilometer cable? Traditional power sources just won't cut it, so scientists are exploring options like laser power beaming and solar technology. Laser beaming would involve shooting a focused laser at the climber, which would convert the energy into electricity to power its motors. This means no heavy fuel tanks or batteries, just clean, renewable energy from the ground. In addition, the climber itself could be equipped with solar panels to harness energy from the sun. As it ascends, it would constantly gather energy, reducing its dependence on ground-based power sources. A hybrid system combining laser beaming and solar energy could offer a reliable, sustainable way to power climbers for the entire journey. This isn't just a solution for the space elevator, it could lead to new advancements in wireless energy and solar tech that could have applications here on Earth too. Building and operating a space elevator would require advanced robotics and automation on an unprecedented scale. Robots would be essential for constructing the cable, assembling the climbers, and maintaining the entire system. Imagine autonomous drones and robotic arms working in coordination to weave sections of the cable, attach climbers, or repair any damage. These robots would need to operate in extreme environments, from the intense heat and winds near the Earth's surface to the vacuum of space. AI-driven automation would also play a huge role in managing elevator operations. With climbers constantly moving up and down, coordinating traffic on the cable would require advanced scheduling algorithms to prevent collisions and ensure smooth flow. Maintenance robots could perform regular inspections, identifying weak spots or wear on the cable and making repairs in real time. This autonomous management system could serve as a model for future mega projects, revolutionizing how we think about construction and maintenance in extreme environments. One idea that has gained traction is building parts of the space elevator in space itself using 3D printing technology. 3D printing could allow us to produce sections of the elevator, like docking platforms or repair modules, without launching every piece from Earth. With 3D printing, we could use raw materials sourced from the moon or even asteroids, making the process more sustainable and less costly. Imagine robotic printers working in orbit, building and assembling parts of the space elevator as they go. This on-site manufacturing would make it easier to expand or repair the elevator over time, adapting to changing needs or fixing issues without having to send materials all the way from Earth. Space-based three-dimensional printing could reduce costs and logistical challenges significantly, and it could lay the groundwork for similar technologies in other space infrastructure projects. To keep a space elevator operational over the long term, researchers are exploring smart materials and self-healing technologies. Imagine a cable that can detect small cracks or stress points and repair itself before any damage becomes serious. This self-healing property could be achieved with specialized coatings or embedded nanoparticles that react to damage by sealing cracks or reinforcing weak points. Smart materials would also make it easier to monitor the health of the cable. Sensors embedded along the length of the cable could continuously send data on temperature, stress, and wear back to a central hub, allowing operators to detect any issues early. These sensors could even adjust the material's properties in response to environmental conditions, making the structure adaptable to changing weather or space conditions. Self-healing and smart materials would not only make the elevator safer, but also reduce the need for constant maintenance, making it a more sustainable project in the long run. Finally, there's the technology that would allow climbers to travel faster and more efficiently up the cable. Some engineers propose using magnetic levitation, or maglev technology, to power the climbers. Maglev is already used in high-speed trains, and the principle could be adapted for space elevator climbers, allowing them to glide up the cable with minimal friction. Electromagnetic propulsion systems could further accelerate the journey, using magnetic fields to push the climbers upward. This would make the trip faster and smoother, enabling high-speed transit from Earth to orbit. Imagine traveling to orbit in a matter of hours, without the need for rocket engines or massive fuel consumption. This technology would transform the space elevator from a slow-moving structure into a rapid transit system, bringing us closer to a future where space travel is as routine as an international flight. No conversation about the space elevator would be complete without addressing the challenges. One of the biggest is, of course, safety. Imagine a 35,000-kilometer cable stretching from Earth into space. It's exposed to everything from Earth's weather patterns to intense radiation and micrometeoroids. A break in the cable could have catastrophic consequences, with fragments potentially falling back to Earth or drifting in orbit as space debris. Engineers would need to plan for every possible scenario, designing the cable to be as resilient and damage-resistant as possible. Another hurdle is anchoring and stabilizing the elevator. The base station on Earth would need to be in a stable location, probably near the equator, and capable of withstanding strong winds, storms, and other natural forces. There's also the challenge of securing the other end in geostationary orbit, where it would remain stable above the same point on Earth. This requires an immense amount of engineering expertise, careful placement, and constant monitoring to keep the structure safe and functional. Building a space elevator would be one of the most expensive projects in human history. The initial investment could be in the hundreds of billions or even trillions of dollars, a cost so high that no single country or company might be able to shoulder it alone. This means we're likely looking at an international collaboration involving public, private, and governmental funding. The question then arises, who will own and operate it? How will the revenue be generated and shared? The economic benefits could eventually outweigh the costs, especially with reduced launch expenses and new industries that an elevator could support. Still, the risk is huge, and securing global funding and interest for such a colossal project is a massive hurdle. We might see partnerships where costs and benefits are distributed among nations, like a global space corporation or an international trust fund that manages access and fees. But all of this would require complex agreements and trust between stakeholders, which is easier said than done. Interestingly, a space elevator could have both positive and negative environmental impacts. The positive side is clear. By reducing the need for rocket launches, we'd cut down significantly on carbon emissions and pollution in the upper atmosphere. This would allow us to access space in a much greener, cleaner way. But, on the other hand, the construction of the elevator itself would require immense amounts of energy, materials, and possibly disturbing ecosystems near the base location. Imagine the environmental footprint of building the infrastructure, transporting materials, and producing advanced materials like carbon nanotubes. These are things we'd need to consider and mitigate. Could we build the elevator sustainably? How can we ensure that the base station and cable don't disrupt marine life or local environments? Addressing these questions is crucial, as the space elevator would likely become one of the largest human-made structures on the planet. A space elevator would need to navigate through layers of space that are already crowded with satellites and space debris. Even a small piece of debris hitting the cable could cause serious damage, so the system would need to account for this risk. Engineers are exploring ways to shield the elevator or deflect objects, but it's a huge challenge given the amount of debris orbiting Earth. Some suggest that space debris cleanup programs could work in tandem with the elevator project, ensuring a safe corridor for the elevator cable. The possibility of satellite collisions is also a concern. With thousands of satellites in orbit, we'd need to carefully coordinate the elevator's position to avoid interference. This could mean rerouting satellite traffic or creating new orbital regulations to protect the elevator. It's a massive undertaking that would require coordination across multiple industries and countries, potentially sparking a new era of international space governance. The ethics of building a space elevator are also important. Who gets to decide who uses it, and how will access be regulated? There's the potential for this technology to deepen inequalities if access is limited to only certain countries or corporations. We'd need to ensure that the space elevator is managed fairly, with guidelines to prevent monopolization or excessive pricing. This project would be a monumental step in human history, and it's crucial to consider its social implications and ensure that it benefits humanity as a whole, not just a privileged few. There's also the question of safety for workers involved in constructing and maintaining the elevator. Would the space elevator create new jobs? Likely yes, but they would be highly specialized, requiring rigorous training and safety protocols to protect workers in extreme environments. Ultimately, if successful, a space elevator would represent a massive leap forward for humanity. It could make space accessible to ordinary people, open up new opportunities for exploration, and serve as a foundation for further advances in space technology. Imagine a future where taking a trip to space is as easy as boarding a plane, where resources from space fuel new industries, and where Earth's environment is protected thanks to cleaner, more efficient access to space. A fully operational space elevator could be the springboard for humanity's journey to become an interplanetary species. It would be a symbol of our capacity to dream, innovate, and cooperate on a global scale, redefining our relationship with space and potentially transforming life on Earth. This vision isn't just about a structure, it's about what it could mean for all of us for generations to come.